This is part F, practice, practice, practice. We're going to match each graph with its equation. So I'm just going to move this down a little. Okay, so let's look at the first equation. Well, I guess the first question we ask is, should we look at the equation and match it to the graph, or look at the graph and match it to the equation? Well, let's start with the first equation. We'll do that this way. X plus 8 quantity squared. Now we know that this is a horizontal translation, left 8 units, which is going to put the vertex at -8, 0. And the graph opens up, meaning that this is graph A. So letter of graph A. Let's do that again. Let's look at -x plus 8 quantity squared. The translations are, again, a horizontal translation, left 8 units, followed by a reflection in the x-axis. So this will be graph H, basically the reflected graph of graph A. Next, we have x plus 5 quantity squared. That is a horizontal translation, left 5 units, and a vertical translation up 4 units, which will put the vertex at -5, left 5, and +4. So if we look for the vertex at -5, +4, here it is, and this is graph B. Now let's look at x minus 5 quantity squared. That will be a horizontal translation, right 5 units, and then up 4. We're looking for the vertex at +5 and 4, which is here, and that is graph G. So let's move back over here and write in a G. X minus 2 quantity squared, -1. This is a horizontal translation, right 2 units and down 1 unit, putting the vertex right 2, +2, -1. But we have two curves here. This curve is congruent to y equals x squared. There is no stretch factor, meaning if I move over 1 unit, then I should go up 1 unit. That puts us on this curve here, which is E. Now the next one we have the exact same. It's 3x minus 2 quantity squared -1. This is right 2, horizontal translation, right 2, down 1, so putting us at +2, -1, vertically stretched by a factor of 3. So if I go over here, then if I go over 1 unit, I should go up 1, 2, 3 units. Here, this point is on the graph, and this is graph F. Okay, we have A, H, B, G, E, F, which means we don't have C and D. Let's see if we can go look at C and figure out what's going on. We have a vertex at -3, -2. So this will be x plus 3 squared, and then a -2. This graph is not congruent to y equals x squared. If I go over 1, I go up 1, 2. It opens up. This will be 2 bracket x plus 3 quantity squared -2, which puts us right here, and this will be graph C by process of elimination. Or let's take a look. So our vertex for D is here at -3. That'll be an x plus 3 quantity squared. We're up 2. It'll be a +2. This is congruent to not y equals x squared. If I go over 1, I don't go up 1, I go up 2. Congruent to 2x squared, giving us 2x plus 3 quantity squared +2. And that is graph D. Okay, let's look at number 2. For each of the following quadratic functions: A, describe the transformations. B, state the coordinates of the vertex. C, Use your knowledge of transformations to accurately, that's bold, draw the graph on the grid on the next page without the aid of a graphing calculator. We'll do that by finding the vertex, by determining whether it opens up or down, and by using the number in front as our stretch factor to graph that. I'm going to leave you to look at these graphs. There's no way with my present pen skills that I'm going to draw them accurately, but you can get the drawn graphs for all of these on the PDF of the answer sheet. Okay, let's look at equation A. Oops. Y equals -3 x minus 4 quantity squared plus 5. Okay, let's start out by finding the vertex. So where is this? We know that it's moved right 4 units and up 5 units. Right 4, up 5, puts the vertex at 4, 5. We stretch the graph of y equals x squared vertically by a factor of 3. Remember, it's the absolute value of a that we're interested in, resulting in a vertical expansion. Reflecting the resulting graph in the x-axis, so that's the negative sign in front of the 3, causes a reflection. And we have 2 translations to deal with. Translating the resulting graph right 4 units and up 5 units. Okay, so when we go to graph that, we will start with the vertex at 4, 5. We're going to be drawing a graph that opens down from the vertex 4, 5. We'll move 1 unit to the right and go down 3 units. We'll move 2 units to the right of the vertex. Now 2 squared is 4, opens down, we go down 4, but the vertical stretch means we'll go down 12. And then we do the same thing going left 1 unit and down 3, and left 2 units and down 12. Okay, now we're going to do the exact same thing for B, C, and D. This transformation, x plus 6, says go to the left 6 units, putting the vertex at -6, and go up 1 unit, so the vertex is at -6, 1. So the new parabola, and I'm just going to abbreviate this, it's a vertical stretch by a factor of 2. There is a horizontal translation, left 6, and there is a vertical translation, up 1. Moving on to C. So the first thing we look for, there is no stretch. There's no number in front of the negatives or behind the negative sign and in front of the brackets, but we do have a negative. Vertex first. So this is left 3, putting the vertex at -3, and up 2. So vertex is at -3, 2. There is no stretch. However, with the negative sign, there is a reflection in the x-axis. So reflection in x-axis, followed by a horizontal translation, left 3, and a vertical translation, up 2. Next one, vertex. In this case, we have a stretch and a reflection, but there are no translations. Stretch and reflection will leave the vertex unchanged. So the vertex is at 0, 0. We have a vertical stretch by a factor of 3. Three. We have a reflection in the x-axis. Reflection in x-axis. And that's all that's happening here. Okay, last one, E, for the vertex. And again, for the vertex, we're just interested in the left and the right. Since a stretch or a reflection will not change a vertex of 0, 0, the only thing that can affect that is a horizontal translation. So we have a horizontal translation, right 2 and down 1, putting the vertex at 2, -1. That's kind of, I don't even know where the eraser is on here. It's not written great. Let's do that again. 2, -1. There. Okay, now we need to describe in words what's going on here. So first we start with stretches. We have a a vertical stretch, VS, by a factor of 1/2. We have a horizontal translation, HT right 2. And we have a vertical translation, down 1. Okay, so now as far as doing all of the graphs go, what you need to do is just go look at the sheets to find the graphs sketched on there. They'll be sketched very nicely and not have to deal with my kind of shaky graphs. And we'll finish this off. So in summary, the graph of y equals a, x minus p, quantity squared, plus q, will have a vertical stretch by a factor of the absolute value of a, and will be vertically expanded if the absolute value of a is greater than 1, and will be vertically compressed. Sorry, I think I said less than 1 if it's greater than 1, and will be compressed if the absolute value of a is less than 1. It will open up if a is positive, so we're just going to say a is greater than 0, and we'll open down if a is negative, that's a is less than 0. It has a vertex at PQ. Remember, that's the horizontal and vertical translations, and those are the only things that affect the vertex. Since it's at 0, 0, it will not be affected by a stretch or a reflection. And has a vertical axis of symmetry. We know that passes through the x-coordinate of the vertex of x equals p. So that's our summary of part F for the work we didn't get to in class. We'll start off on Monday on the next class and go over any questions you may have. Thanks.